Okay, we're going to go ahead and start today's lesson. Tonight I'm recording this, so those of you who are still working on quizzes can continue. Today we're going to talk more specifically about box plots. So yesterday we talked about different ways of visualizing data, and today we're going to focus more on box plots because that's what you're most likely to need to answer questions about. We're going to talk about interpreting them, comparing them, both of which we did last year in 7th grade, so this should be somewhat of a review. Number 3 is a little different. Number 3 is determining whether there are outliers using the 1.5 IQR rule. So that one's the one that's completely new to you this year. The others hopefully will be a review. Okay, box plots are a measure of central tendency because they clearly show the median. So the median is a measure of center. When we look at a box plot, we can see the median right on. There's no calculating. We know what it is. So it is a measure of central tendency in that way. They are also a measure of dispersion. What does dispersion mean? Think about not just in math, but what does the word dispersion mean? Gretchen? Dispersed, and what does that mean? You're doing it with your hands, but can you describe it? It's spreading throughout. So she's showing spreading with her hands. It's spreading throughout. So dispersion shows the range, or how far apart the data is spread. We see the range, and we can also see the interquartile range, which is that distance between the two, the upper and lower quartiles. And we refer to that as the IQR. So in Objective 3, where it's talking about using the 1.5 IQR rule, that's what it's talking about, the interquartile range. Box plots also tell us what percent of data falls within a certain range. Each quartile is 25% of the data. So we have 5 quartiles. Our first quartile is 25%. The second is also 25%. And the next one is 25%. And the last one is also 25%, which altogether add up to 100%. So it's 100% of the data. It's arranged into these quartiles. Each quartile has the same number of data, so we can tell a little bit about how far the data is spread out by how long each quartile looks on the box plot. Okay, that leads us into our first objective of interpreting. We're just going to take a look at this box plot and talk about it. Rosa, what was the high score on the test, according to this? No, actually not the high score. Gretchen? 102. The high score is the highest one that's on there. 96 is the top of it's the upper quartile, but 102 is the high score. What percent of the class scored above a 72? So here's 72. Think about how many quartiles we have above that. Gabby? Good. 75%. So we have 25% here, another 25%, another 25%, 75%. What was the median score on the test? TJ? 88. Good. 88. Median's right there in the center. What percent of the class scored between 88 and 96? Lacey? 25%. Good. Okay, number 5 is kind of an opinion question, and you're to explain. Do you think that this test was too hard for the students? And explain why. So think about that for a minute, whether you think it was too hard and why. Athena?
Because most of the students passed. I think it was just an outlier. One or two people might have failed it.
Mm-hmm.
I think that's what caused such a long number.
Okay, so you're saying you think it was a fair test. I'm just going to repeat some of this so it picks up on the recording. You think it was a fair test. This 38 was probably an outlier. It was probably some student who just blew off the test and maybe didn't study at all. But most people passed, so it was probably a fair test. It was probably not too hard for the students. Okay, good. I'm not going to write all that out now, but you can write that down on yours. Would you expect the mean to be above or below the median? This is kind of a interesting question. Would you expect the mean to be above or below the median? Olivia?
I think it would be below.
Why?
Because there's an outlier.
Yeah, good, good. It would probably be below because we have that outlier. And when we have an outlier, the median is a better measure of center. It's a better, 88 is a better measure than it would be. We can't find the mean just from the values on our box plot because we don't know what all the values were. But we would guess the mean might be below because of the outlier. Okay, the next one is one for you to go over, so I'm going to give you a couple minutes to answer the next questions 1 through 5. And then we'll talk about this briefly. Okay, guys, we're going to go over this even if you didn't get the whole way through the whole thing. Number 1, volunteer, since some people are still working on this. Lacey? Good, 25%. Number 2, different volunteer. Colin? Good, 20 to 60 minutes. The middle 50% is from here to here, and that ranges from 20 to 60. Number 3 is kind of an interesting question. How many students do not do homework? Rosa, what do you think?
19.
What's that?
19.
19? Okay, so you're thinking 0 to 20, but we don't actually know how many students are represented in each quartile because we don't know how many students there are total. So those numbers actually don't tell us anything about how many students there are. Athena?
At least one, because if there wasn't at least one, then there wouldn't be a 0.
Okay, that's an excellent answer. She said at least one. If there was not one who did not do homework, there would not be a 0. The fact that there is a 0 on this chart in the first place tells us that at least one student had to have spent 0 minutes on homework, otherwise that minimum value would be a different number. Okay, so at least one, but we don't know how many. There's no way to tell how many unless we knew, well, even then we could tell how many were in the range from 0 to 20 if we knew how many students there were total represented in this box plot, but we still wouldn't know how many were exactly in that 0 range. Okay, number 4. Volunteer? Gretchen?
25%.
Good, another 25%. And number 5, another volunteer. Gabby? What's that? Why do you think it would be lower? Okay, but where's the outlier? Is the outlier in the low direction or in the high direction? It's probably in the high direction, so that would make the mean higher. It would probably be higher. Okay, any questions about any of these? Okay, next objective is comparing box plots. So we have 2 box plots that we're looking at, and the questions about these box plots go on into the next page, so you'll have to look back a little bit. So we have the first box plot is showing us how many minutes per night students are spending on homework, and then the second box plot is telling us how many minutes students are spending watching TV. And we're to answer true, false, or undetermined. Number 1 says some students didn't watch TV that month. Lacey? True. How do we know that? There's a 0. If there was no one who had 0 minutes, then we would have some other minimum. If the lowest was 5, our box plot would start at 5. Okay, the TV box and whisker graph contains more data than the homework graph. Gretchen?
That's false.
False? Why?
Because there's more of an area between box, so that's why there's more data. Actually, because that means could be more considerable.
Okay, so wait, you said it's false, so the TV box and whiskers did not contain more data, but then you kind of said it did because they were bigger. I don't know. Zane, what do you think? Undetermined, why? Okay, we don't know. I agree with your answer because we don't have more information. If these were comparing the same group of students, then the number of data in each box plot would be the same, and the answer would be false because it would be the same. But we really don't know. This doesn't actually tell us that this was comparing the same groups of students. So I think undetermined is a fair answer for this. If you also put false, assuming that it's the same group of students, that would be okay too. So we can't tell from the length of our box plot how much data is represented in the box plot. We can only tell how far spread out it is. The longer it is, the more spread out it is. Okay, number 3. 25% of the students, you guys may want to leave your thing open to your first page so you can look at the box plot. Or actually, let's keep mine there. 25% of the students spend between 48 and 60 minutes per night on homework. True, false, or undetermined? Maddie, here's some notes. Okay, Lacey? True. So if we look at the homework graph between 48 and 60, that's one quartile, so that's 25%. So the answer to number 3 is true. Okay, number 4. 15% of the students didn't watch TV that month. I want to see more volunteers. Didn't watch TV that month. Sophia? Undetermined. That's correct. We don't know how many didn't. We don't know how many people make up that 0 value. It could be 15%, but we don't know. In general, these students spend more time watching TV than doing homework. Liz, what do you think? True. I would definitely say true because the maximum is higher for TV time. The median is higher for TV time. So in general, I think it's safe to say that they do spend more time watching TV. Number 6, the TV data is more varied than the homework data. Zan, what do you think? True. Why? Yeah, the range is bigger, it's more spread out. Number 7, the ratio of students who spend more than 110 minutes per night watching TV to those who spend less is about 2 to 1. Think about that one for a minute. Figure out if that's actually the right ratio. Students who spend more than 110 minutes per night watching TV. So more than 110, the ratio of this to this, they're saying, is 2 to 1. Athena?
That's false. It's about 1 to 1.
Mm-hmm. Well, it is false, I agree with you, but it's not 1 to 1. Can anyone tell me what it is? Gretchen? It would be 1 to 3. Each one of these, we're down here. Each one of these sections is equal. So this one is the same amount of data as the other 3.
I thought you were talking about the entire half after the...
No, just talking about the entire graph. So the ratio would actually be 1 to 3. So false, it would be 1 to 3. Okay, number 8. 225 students watch TV. Zoe, what do you think? Okay, you said false because we don't know. So a better choice than false would be Undetermined, yeah. We don't know. It could be actually true. We could have thousands of students interviewed, and there actually could be 225 students who watch TV, actually, out of thousands. Probably, maybe they interviewed 226 and 225. We don't know. But most likely, it would be undetermined, because we just don't know. It's possible. Okay, last objective. Let's see how we're doing for time. We're doing well. IQR stands for what? I already told you guys this once. Kat?
Interquartile range.
Good. Interquartile range. And when you're finding the interquartile range, you're just looking at the difference between the upper and lower quartiles. So if we go back to the box plot, the interquartile range for homework time would be what? 40. How about the interquartile range for TV time? Athena? 60. No, we need to go from 15 all the way to 110. Rosa? 95. Okay, now this is kind of an interesting little formula. To determine whether there are outliers, here's what you do. You multiply the interquartile range, so you find the interquartile range, you multiply it by 1.5. Then you add that result to the upper quartile. Any values that are greater than that number are outliers. You subtract the result from the lower quartile. Any values less than this are outliers. And let me show you how this works. So in this box and whisker plot, we first need to find what the interquartile range is. That was step 1. So the interquartile range is what? Gretchen? No?
Oh,
38. The interquartile range is 38. 73 minus 35 is 38. Okay, now we're going to take our interquartile range and multiply it by 1.5. So you have to think about 38 adding on half of 38. So 38 times 1.5 works out to be 57. Okay, then what we do is we go to our upper quartile, which is 73. To see if 80 is an outlier, we add 57 to 73, which, I mean, you can tell just from looking at that whether we actually do the math, that's going to be bigger than 80. So we don't have any outliers in the upper quartile. We do 73 plus 57, we get 130, so there's no outliers in that end. This fits within that range that we've just created. On the other end, we start with the lower quartile and we subtract the number that we got up here, the 57, and we get negative 22. So we could go all the way to negative 22, and those would not be considered to be outliers. Okay, what I would like, we don't have very much time. Let's go back and look at the homework plot and the TV plot. Let's look for outliers there. Let's do the average minutes per night spent on homework. I'm just going to do it with you because we don't have a lot of time left. Okay, so I'm going to look at this graph because this one looks like it has an outlier, right? So we might get an outlier. Okay, so my first step, my range is 40. What would my range times 1.5 be? Think 40 and then half of 40. Add those together. Lacey? 60, okay? So we have 60. We're going to add 60 to 60 to our upper quartile. 60 plus 60 is 120. 190 is way bigger than 120, so we can say with certainty that this one is an outlier. Going to my lower quartile, if I subtract 60 from 20, I get negative 40, so 0 is within that range. So 0 is not an outlier. So this looked like an outlier. By using that formula, we proved that it is an outlier.